Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over how to solve absolute value inequalities. Don't forget to visit our website at mathgotserved.com for access to a wide variety of math tutorials ranging from algebra all the way to calculus. So let's take a look at the instructions for this example. So we are to solve each inequality and graph the solution on a number line. Okay, so for problem number 1, we have the inequality 6 plus the absolute value of x is less than or equal to 12. Okay, now anytime you're solving an absolute value inequality and you have a less than or less than and equal to, this is a sandwiched situation. Okay, your solution is going to be bounded between two regions, so you want to keep that in mind. Okay, so let's go ahead and solve this. First goal is to isolate the absolute value quantity, and then you get rid of the absolute value quantity. All right, so let's go ahead and isolate this absolute value of x first. To do that, we have to subtract 6 from both sides. That yields the absolute value of x is less than or equal to positive 6. Now what we're going to do is we can express this absolute value quantity as plus or minus x is less than or equal to 6. Now, since we have a less than, we can write this as a sandwich situation. This can be written as negative 6 is less than or equal to x, and x is less than or equal to 6. Okay, anytime you have an absolute value inequality with less than or equal to, you can always express it like this as a sandwich or bounded inequality. All right, so we already have x by itself in the center, so this is the solution to your absolute value inequality. Okay, all right, so let's go ahead and represent this solution with a graph. So what does this solution mean? This solution means any number that is between 6 and negative 6, including 6 and negative 6, are part of the solution set. Okay, so let's go ahead and illustrate that with a graph. So let's make it long enough. I'm going to graph 0 first, 0 at the center. So we have 0, 1, 2, 3, 4, 5, and then we have 6. And then in the other direction, we have negative 1, 2, 3, 4, negative 5, and then here is negative 6. Okay, so we're going from negative 6 all the way to 6. So we have negative 6 all the way to 6, and everything in between. So let's go ahead and draw our number line, and then this is the inequality right here. Okay, so the question is, are we going to have open or closed circles at the endpoints? Is negative 6 and 6 included? The answer is yes. Since you have lines, a dash underneath each inequality, that means you have to include the endpoints with a closed circle like that. All right, so that's your solution, the graph of your solution. All right, let's take a look at another problem, question number 2. So for number 2, we have negative 1 plus the absolute value of m is greater than or equal to 8. Okay, so let's go ahead and isolate the absolute value quantity and determine if it's a sandwich situation or not. Okay, So first thing we are going to do is add 1 to both sides. If you add 1 to both sides, you have the absolute value of m is greater than or equal to 9. So we have isolated the absolute value quantity. Now, since this inequality is a greater than or equal, it's not a sandwiched situation. Okay? Remember, sandwich is only when you have less than or equal to. Okay, this is a sandwich situation. All right, but if you have greater than or equal to, it's going to be a separated inequality, a disjunction. Okay, all right, so let's go ahead and solve this. Now, this is going to be written as plus or minus m is greater than or equal to 9. So let's take a look at what we did in number 1. Notice how I progressed from this step to this step. I sandwiched x between 6 and its opposite. Remember, you can only do that when it's less than or equal to. Okay? When it's greater than or equal to, it must be separated. You can't have it. You can have you cannot have the variable sandwiched. Okay, so for greater than or equal to, you must separate the two cases. So how do we separate it? Well, we're going to have it in the following format. We're going to have either negative m is greater than or equal to 9, or positive m is greater than or equal to 9. Okay, so we must separate this case, or this combined inequality, anytime we have greater than or equal to. So we must separate it. Okay, so we're going to solve them independently. On the left side, we need to get m by itself. So we will just divide both sides by -1. Now, anytime you're solving an inequality, do not forget to switch the inequality symbol when you divide by negative. Okay, so m is less than or equal to -9, or this is already solved. M is greater than or equal to 9. So this is the solution to question number 2. Okay, all right, let's go ahead and graph our solution. Another thing to note about greater than or equal to is that your solution region is always unbounded. Okay, whereas for less than or equal to, your solution region is bounded. Okay, that's what it means to be sandwiched. Okay, so let's put 0 at the center. We have 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. So for here we have a circle greater than. We're going to be pointing towards the right, because that's the direction of increasing magnitude on the number line. And then we're going to go -1, 2, 3, 4, -5, 6, 7, 8, -9. We have another point here. Less than means you're going to be pointing in the left direction. That's the direction of decreasing magnitude on your number line. Okay? Next question. Are our points going to be filled? Are they going to be closed or open circles here? Since we have lines underneath our inequality, this is going to be a closed circle, and that is going to be a closed circle. So there goes the graph of our inequality, okay? Our absolute value inequality, so that's that. So thanks so much for taking the time to watch this presentation. We really appreciate it. Feel free to subscribe to our channel for updates to other tutorials such as this. If you have any questions or would like to request any tutorials to be made for you, just indicate it in the comments section below this video and we'll be glad to address it. More clips can be found on mathgodserved.com. Thanks again for watching and have a wonderful day.